welcome to our third brown bag session of the year. Today's topic is the 2018 Forecasting Accuracy Survey, benchmarking survey that we conduct every year. If you haven't met me before, my name is Mark Kwan, and I'm in Itrom's West Coast or San Diego office. So welcome. It's hard to believe it's already September. We do this presentation each year, but you know, it's September, so we are 3/4 of the way done with the year. The weather's getting cooler, kids are back in school, and as it's becoming our annual tradition, we get a chance to take a look at the survey results that you had submitted earlier this year. As we start, just a quick reminder that your phones should be muted. We've muted them from our end, but in case we hear some background noise, just make sure your phones are muted on your end. There are a couple tools on the WebEx site to expand your windows on your computers to see the full screen. We are recording this session for downloading and listening to later. And finally, for questions. If you do have questions, go ahead and enter them in the box. I do have that question box on my screen, and if I'm not too distracted, hopefully I'll be able to answer your questions verbally or and written after the presentation. So with that, let's go ahead and begin. If we sit back and think about the 2018 survey overall results, I think there's two general themes that are going to come forward today. The first is there are no dramatic surprises. We are looking at continuations of trends that we've seen developed over the last 6 or 7 or 8 years since we've been doing the survey. But there's some interesting insights, I think, in the nature of our jobs as forecasters. To kind of lay the groundwork, we show this slide every year, and we've been updating it every year. The slide shows the United States electricity sales. The blue line is residential, red is commercial, and green is industrial. The numbers are computed as 12-month moving sums, and the gray bars are recession. Most of you have seen this slide before, and it shows the flattening of sales, the hinge point around 2008, and the flattening thereafter. Now, what becomes interesting about this is we are in what most economists are calling a late cycle growth or late expansion, late cycle expansion, which means that most people are predicting a recession coming soon, although they don't seem to know when that might be. What this slide tells us when we think about the impending recession that may be happening is how often those trends remain the same before and after the recession. So going back to '74, back in the early 80s, the early 90s, the early 2000s, and the only exception really being in 2008, you see that the recessions come in, we'll see some movement in sales, but the trends before the recession tend to be the same as after the recession. So if you're starting to think forward of what your forecasts are going to look like, and you're getting questions about impending recessions, so long as your forecasts pick up the overall trends, you should be able to roll right through those recessionary periods in a nice, consistent way. The second thing this picture is starting to show is that for the first time, we have 10 years of data post-2008 recession. And this becomes interesting because for many of us, 10 years of historical data is sufficient for us to generate our long-term forecast, which means, of course, that we can generate our forecast now with all post-recession data. That has some implications, of course, for the type of economic drivers that we're going to select or we might select, as well as for accuracies that we will see coming out of our forecast. But the bottom line is with 10 years of post-recession data, the opportunity to shorten those estimation periods is starting to come forward. Now, the next slide, of course, is the same information rolled up into an aggregate level, and you can see, once again, a reiteration of the flattening of sales. We've been collecting these next few slides since we've been presenting on the survey. We got these pictures way back to 2011. I've got here the last 3 years of weather data showing departure from normal temperature. So in the upper left-hand picture, you see departure from normal on the cooling side, and in the lower right-hand corner, you're going to see departure from normal on the heating side. And in the upper right-hand corner is a zoom in of those 12-month moving sums, so you can see how sales are moving in relation to weather. I saved these last three mostly because they're the most recent, but they reveal kind of an interesting picture of what we've been seeing in our recent history. Now, in the 2015 time period, we're seeing a lot of yellows and greens in the cooling side of the chart, which says we're very close to normal across the country. In the lower right-hand, we're seeing a lot of oranges, yellows and oranges, which says we're probably a little bit warmer than a normal on the heating side. Sum total, we're looking at a year that's fairly normal. If we roll that forward to 2016, we see much the same picture. The colors shift around, but you're seeing a mild summer and a warm winter. And if we move one slide forward into this last year, 2017, we see once again something similar, a warm winter and a fairly mild summer. Now, if we roll through those again, pay attention to the upper right-hand corner. Here's 15 in the red box, 16 in the red box, and then 17 in the red box. And as much as we like to think of sales being flat, as we roll through 3 years which look fairly normal, we notice that the blue line has a slight downward trend in it. And the red line, the commercial sales, has a slight upward trend in it. So in 3 relatively similar overall weather years, we're seeing a little bit of movement in the data, in the sales data. Residential continuing to decline, and of course commercial showing a slight increase. So even when we flip back and we look at the overall sales picture here, across all 40 years or so, it looks very flat. There seems to be some subtle movements that we should be thinking about. Now that, of course, gets us to 2018. Now the survey doesn't cover 2018, but I put the slide in mostly because I don't know about you, but San Diego feels like it's been very hot. So looking in the upper right-hand side, which is the departure from normal cooling degree days, this is the summer year, we're starting to see a lot more of these deeper reds come through. So as we start weather normalizing 2018 and we're looking forward to where we might end up in 2018, we're probably for the first time in about 3 years looking at something that is slightly hotter than normal. The left side is the departure from normal on the heating degree day side. It looks like we see some blues and purples coming in the northern part of the country, so we may be headed for a slightly colder than normal winter. Now, the caution, of course, is these are 3-month segments. The winter in the upper left, we don't know what the winter is going to be like coming in the final quarter of this year. I'm not showing springs, I'm not showing falls. So it's a really quick snapshot of what we should be thinking about as we go through this year. I clipped just something off the internet about the 2018 summer. I know for my family, we had family members in 3 continents this year, and it didn't matter what continent you were in, it was hot, whether you're in Asia, in Europe, Africa, or North America. So we are looking at a hot summer, which will have some implications, of course, for where we might be going next year. But that's how the weather sorts out. We're looking at, once again, in our numbers, we flip back a slide, fairly normal 2017. On the gas side of the house, we're seeing a similar view to the electric side. Once again, no surprises here. We're seeing a continuing flatness in residential, commercial, and transportation sales, and the gas side of the house seems to be being propped up on those with the industrial sales. What is interesting is that if you start rolling all those numbers up to a total system, we are very close to the historical maximums across the last 40 years of data. When we see the same picture of how those sales move with specific weather, we're showing only the heating side for the natural gas sales. The blue line is residential, the red line is commercial. And we noticed, in particular, those last 3 winters being fairly normal. We see on the residential kind of a nice flattening. And these are 12-month sums, so they tend to be trailing. So we're kind of looking at the endpoint. So the 2015 numbers for the year are going to be sitting right around, oops, let me get the pin going, right around this level. Mild winters, and we see mild winters coming all through here. See if I can get the pin working. Kind of coming all through here. And what I like about this view is that when we think about our gas systems, especially on the residential side, there seems to be 3 levels. There's the cold winter, there's kind of the normal winter, and then there tends to be the mild winters. So we see mild or fairly normal 2018 showing on the electric, on the gas side. And in terms of other key drivers that you might be thinking of, prices continue to remain flat in real terms, which is, of course, a very interesting thought. I know at least in California, our rates seem to be rising. But across the United States, we're showing through 27 flat prices in real sense. And same on the gas side, slow declines in real gas prices. So that's kind of a look at where the overall trends are going. Let's dig into the survey and see what kind of answers you have for us this year. This year we had 74 total electric responses, 16 gas. Numbers are very consistent over last year. Draw your attention primarily to the Northeast and West region. As we sit back and think about the survey responses across the country, the West and the Northeast tend to have the smallest representative samples, which bring in a little bit more noise and uncertainty of those numbers. We feel really good about the annual, or really good about the national numbers as they roll across all utilities. In fact, the total response is some 60% of kilowatt and hours sold in 2017. So very large samples across the United States. But the individual regions start becoming a little bit troublesome. So for the most part, we're only going to be showing annual numbers. The report will list out some of those more local numbers. Once again, you want to take some of those local numbers with a little bit more skepticism, especially out in the West. To the extent we're showing regional numbers, these are the regions of the country. We divide our results into the 4 regions: West, Midwest, Northeast, and South. Sometimes it's useful just to understand what region you're in as we roll through the data. So our first questions always deal with customer growth. These are national numbers, or total survey numbers, national meaning United States and Canada, and we looked at for the last 8 survey years, or 7 survey years of 1 forecast year, 28, what were your annual average customer growth rates? The blue are residential and the red are commercial. What you see here is in 2011, 12, and 13, the increasing customer growth rates. And then they start to level off around 2014. So the numbers between 14 and 16, as well as 17, tend to be fairly consistent. You see that more dramatically on the commercial side than on the residential side. I think the story becomes the same, is that in terms of customer growth, we're looking at the forming of some stability in terms of the residential and commercial customer counts. In the box below, I put the 2012 to 2016 average. So over that 4-year period, or 5-year period, the residential annual average growth rate is 0.83%, and commercial growth rate is 0.82%. Very similar. You can see there's a little bit more movement on the residential side than on the commercial side, which plays into the question of, well, what's happening in 2017. 2017, we see a little bit of movement outside those bands. The residential is higher than the 0.8, the commercial is lower than the 0.7, and the forecast then that you are using is slightly over 1%. South and West regions tend to drive customer growth in the overall picture. But I think if we think and sit back and try to summarize what's happening in customer growth, we're really looking at growth at 1% or less based on historical averages. The only reason that the growth rate should be sliding above that 1% is if we see more dramatic, say, population or household growth in service territories or in specific regions. Moving over to the sales side, we'll begin with the residential sales growth rates. We have two sets of data here. The blue line, the solid blue line, represents the survey responses. And what we started doing 2 years ago is we internally have been taking the EIA data and weather normalizing it by region. So we can get an independent picture nationally of what those what those growth rates might be. These numbers are very consistent. In the lower right-hand box, the 12 to 16 averages are showing the survey average of about 0.24%. The Itrom number comes in around the same 0.2%. The growth in sales tends to be in the Canada, southern, and western regions. The 2017 numbers come in very consistent with that. The survey is a 0.16. I actually don't label our weather normalized growth rate. And we'll talk about that when we start looking at the commercial, but we want to take the 2017 weather normalized numbers with a bit of skepticism until we roll around to next year. The forecast sits at a 0.41%, slightly higher than the historical averages. So most of you are thinking something's going to be propping up sales a little bit more. But taken together with customers, you have customer counts growing at about 1% forecast on a forecast basis, sales growing at about 0.4% on a forecasted basis, and of course the implication, not only on a forecast basis but on a historical basis, is that we have declining use per customer on an annual basis. Moving forward into the commercial growth rates, we see a similar picture. The surveys showing responses slightly over 1%. Floating, I got here floating at the 0.4%, 0.43%, but you can see over the last couple of years we're really down in the 0.2%, 0.3% range. The Itrom numbers are fairly consistent with the survey numbers, and of course I'm pointing out in this picture the 2017 weather normalized numbers showing negative. Now, it's important to note when we weather normalize numbers that we get that historical data from the Energy Information Administration, which is data that you ultimately report out to them. So they are representative. But what we've learned since last year, and we also understand is this year, is that those numbers seem to come into the EIA on a lag basis. So when we develop our weather normalized numbers, these numbers are representative of data through 2017, and then the EIA by December 18 will go back and revise the 2017 numbers. We saw that dramatically last year. When we did the presentation, the 2016 numbers showed a large negative, and you can see right here that the 2016 number is now revised very close to 0. So this number here we take with a little bit of caution. We expect upward revisions over the course of the next year. All right, so that's the commercial growth rates. Industrial, we don't weather normalize industrial. The industrial growth rates are floating around a 0.3%. Had some negative years in 15 and 16. They seem to be returning back to positive growth in 17 with a forecast up at about 1%. Well, we think this is related to the economic expansion. The economy seems to be doing well. We see production up, and we think that is going to be driving electric sales. Aggregated at the system level, the numbers roll together to about, call it a 0.25% growth rate. Historically, we've seen over the last 5 years about a 0.3, and on a weather normalized basis, call it a 0.2. So all the numbers are right where they should be, and the forecast gets lifted here And I think the forecast lifting is primarily going to be due to the industrial numbers running at about 1% in the forecast. The peak growths are shown here in red. And for comparison, I'm also showing the system growth rates, the sales growth, the system energy growth rates in the dotted line. Historically, peaks are growing at about 0.15% on a 5-year average. 2017 it's down, it's showing a negative number from the survey at 0.28, and the forecast seems very high or very aggressive at a 0.14. The peak growth rates tend to be a mixed bag, and I think there's probably some work to be done here at breaking out peak growth rates related to summer versus winter peaking utilities. So we'll ask a question about that later. But I think it's the nature of the summer versus the winter peaking that you're seeing so much movement in the growth rates as they bounce around. So that's the picture of growth. We're looking at sales coming in, call it 0.5%, around 0.5%. We see customers coming in maybe around 0.8 to 1%, and peaks moving around dramatically. You can see that the peak growth and the energy growth don't necessarily match, and I think we're starting to see that, of course, the shifting of the peaks coming in through some of the parts of the country due to behind-the-meter generation. The next set of questions that we had in our survey relate to forecasting characteristics. We've been asking this question since 2012. The question is whether you include electric vehicles or you include photovoltaics in your forecast. You can see the percent of utilities that do include electric vehicles or photovoltaics in their forecast. That's what these are, the percent included. And what you notice is that through the 13 to 16 period, you see an upward trend here of people including those components. What you've seen over the last year, and what's interesting now about the 2018, is these numbers feel like they're starting to stabilize. Which means that if you've been including these components in your forecast, you seem like they're a natural part of your forecast now. For the first time, we asked whether you included battery storage or some sort of energy storage. This would be on the behind-the-meter side in the forecast. Of the responses of people including storage in the forecast, 19% said they do. 81% says that they don't. Once again, so storage is a new question. Very small number of utilities reporting they're putting something in for forecast. Most people aren't. Now, if you start looking at the storage market, a recent report that came out from Woods, McKinsey, Power and Renewable Energy Consulting, and the Energy Storage Association cite that storage or retail storage is starting to grow in California and Hawaii. And that's not unsurprising because those tend to be states that have two things going for them. They have solar, large penetrations of solar or a large amount of solar, and they're also moving to time of use rates. And so when you start coupling storage systems with solar systems, from a customer perspective, they're thinking that they can store the power, even though we know that's probably not directly true. But it creates a value stream for those customers, and likewise, time of use rates, being able to dispatch your storage unit when rates are high and then draw from the grid when rates are low, creates potentially another value stream coming out of storage as well. So we're starting to see the conversation about storage increase, and that brings us to the first polling question. Now, our survey asked the question of whether you're including storage in your forecast. And your response was generally no, we don't include any component of storage in our forecast. But that doesn't mean that people aren't asking about storage. So almost as a way for us to begin thinking about storage and how big storage will be as a component of our forecast, we want to open up this poll, and I want to ask a more general question. And the question is this: is your company beginning to ask, that is to ask you, the forecaster, about storage in the forecast? Okay. This doesn't mean you're including it, but you are getting questions from, say, your clients, your executive teams, about storage, potential storage impacts, or whether you see it growing or when it might be included in the future. Not that you're including it. We're not asking whether you're including. We're asking if you're starting to get those questions. Okay, so with that, we've opened the poll up. It looks like Paige has got it up on the right side. The answers are this. When we ask, is your company beginning to ask about storage in your forecast? The answer is yes. My executives are very interested, and they're starting to ask about the impacts. Answer B is, yeah, they're kind of interested. They want to keep their fingers and their pulse on what's going on, but they're not all that worried about it. Question C is no. No one's really asking. No one seems to be interested. And D is no, everyone thinks it's so far off that it's not even on the radar scope. And of course, answer E is, you know, I'm the forecaster, and I have really no idea what my executives think. Okay, so go ahead and open up the poll. Go ahead and give us your answer. We're going to see almost on a forward-looking basis when we think that the storage might hit into our forecast. All right.
We've got about 66% that have answered.
Let's give you a 10 count. Let me give you a 10 count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's go ahead and close it and see what people are doing.
I would, but my mouse just froze. So I'm just going to tell you that 10% said, yes, my executives are very interested. We have 34% that said that my executives are somewhat interested. 13% said, nope, not interested at all. 13% of them think it's still just way out there. And then only 3% said that they don't have any idea what their executives are saying.
All right. So first and foremost, kudos to you that you actually know what your executives are thinking, except for you 3%. 30%, right? So it seems like it's something that's going to be part of our conversation. It will be part of our conversation over the next few years. A growing part, not that we have to do anything about it yet, but gaining a strong understanding of how storage is being adopted, where it's being adopted, and how those characteristics of what storage will look like are things that we need not this year, but in probably the next 2 or 3 years to be able to get our fingers around. And if I'm going to make a real quick pitch for we do our annual conference at the Energy Forecasting Group Conference. This year it will be out in, when is that, Paige? Is that April or May?
Beginning of April.
Okay,
3rd, 4th, 5th.
April 3rd, 4th, and 5th out in Boston. We have invited a speaker out from the Energy Storage Alliance who will be sharing with us their perspective on where saturations of storage are and some characteristics. So not something you want to miss. Great way to educate yourself a little bit on where storage is coming in.
Mark, I'm going to interrupt you for just a second. I can't get my screen to go back up, so I'm going to move to Shannon's office and see if I can get it going from there, and we'll hopefully get the conference up, or the question up. Okay?
Okay. Well, I'm going to roll, I think I can roll forward. Is that right? Okay, well, she's left. I'm rolling forward in the slides, so hopefully you'll be able to see this. For the first time this year, we asked the question of how many forecasts do you generate per year? This question was motivated by several forecasters coming to us just at different times and probably more anecdotally that their executives are asking them to generate multiple forecasts during the year. The question usually comes up in the context of updating the annual budget forecast. And the response of the forecaster tends to be, well, if that's what you want me to do, I'll do it. But then they come to us and say, do you know anyone else that has to do this multiple times a year? So we put that out here almost as a benchmarking question, mostly as a benchmarking question for you, to arm yourselves with a little bit of industry knowledge about how many times people are generating forecasts, and you can see the results here. 48%, call it half of you, generate one forecast per year. I suspect that's your annual budget forecast. I got 23%, call it a quarter of you do it twice a year. And then the next largest is 17%, we'll call another fifth of you are doing it 4 times a year. Now, these are the common periodicities because you got the annual budget forecasting process. The 2 a year is kind of interesting. I'm not sure if that's an annual budget forecasting process plus another forecast, or if it's you do the annual budget forecast and then you do it again 6 months later because they want an update. The 4 times a year seems to be a quarterly update of the forecasting process. That in my mind feels a lot like the budget forecasting process. And then you have a few of these other responses. We got a 2 to 3 times, which indicates some variability. The implication there is that you do perhaps an annual forecast, and there's a couple other special needs forecasts that comes through. We got probably I think 1 response running at 3 times a year. So you could probably bucket the 2 to 3 and 3 times a year and call it a 10%. And then, interesting enough, we did have a few responses where forecasters don't generate a forecast every year. They say they forecast every other year. But predominantly, it's a once-a-year process. Now I'm hoping that Paige is back online. You back online, Paige?
My machine's still rebooting. Give me another couple minutes.
All right. Okay. I'm going to let me queue up the question before Paige actually shows it. The question is this. As we asked the question of how many forecasts you generate, and that's going to, of course, be useful to you. But as I start thinking about the number of forecasts you generate, it begs the question of what types of forecasts are you generating? Okay. So when the polling question comes up, I got a couple questions for you, or a couple ways for you to answer this. I want you to think back at 2017 and what you did. And I want you to think about, did you generate a forecast just for the budget process? Did you do it for the budget process and did you do it for like an IRP? Did you do it for a special study? So I kind of laid out that in the responses, and we want to get an idea of the types of forecasts that you are burdened with. Okay, am I stretching this out long enough, Paige, for you to get a reboot going?
I'm trying. Let me see. I'm back in. And we're on generate. Is the poll open?
I still got a poll open for storage.
And let me close this one and see if I can open this one.
There we go.
There we go.
I see the poll question. All right, so let me walk through those answers again. I generated, in 2017, I generated a forecast for the 2018 budget. That's a once-a-year type thing, your budget forecast. Question B is, I'm doing budget multiple times. Question C is an integrated resource plan. D is a distribution system plan. E is for other, and F is I don't. Hey, Paige, do you know if they can select multiple on this?
No, it's just single answer.
Oh, this is probably an ill-formed question then. I see the problem with this. Well, let's go ahead and answer the survey as best you can, and then we'll probably have to circle back and follow up with this. Are you getting some answers there, Paige?
Yes, we've got about 40%.
Okay. Well, let's do it this way. So even if you answered it, you can still change your answer. I want you guys to answer this thinking about your primary function. Okay? So was your primary function, your primary forecast, the budget or the multiple budgets for an integrated resource plan, a distribution plan, or something else? Think about your first and your primary function.
Okay, we got about 71%. I'm closing it, and it'll be up in 14 seconds, it says.
All right. There we go. We're looking at, my numbers. Let me see. All right, so, you know, we got 50% working on the budget, and a few of you doing integrated resource plans or other purposes. So what that tells us, first and foremost, is that most of you, or pretty much all of you, are doing budget forecasting as your primary job function. I apologize for the ill-formed question. Maybe we'll pursue this next year in the annual survey to understand better the types of forecasts you are responsible for. All right, well, let's roll forward. Those are the forecast characteristics that we were tracking this year. We asked a few other questions which will show up in the report, things like you know, SAE models and whether you're incorporating them. We asked a normal weather question. So there's a few other things that we ask fairly frequently. I think the short answer is there's no surprises, and those answers are very consistent. All right, so the last set of questions here are about accuracy. Now, traditionally, we ask this question of what is your annual forecast accuracy? You can see our survey responses for the multiple years displayed in the table. On the left side, we show the error, the mean absolute percent error against normalized values, and over on the right against actual values. What we always expect is the actual values tend to be higher than the normalized, and that's because you get the natural or the actual weather effects coming in. I'm mostly interested in the normalized values, and of course the 2018 numbers are shown here. Now, when we think about the annual numbers, we've never been very explicit about the reporting these numbers, and this is the first year which we became more explicit and called these annual forecast accuracy or annual forecast error. And what we mean by that is when you look at the energy for the year compared against the energy you forecasted, what are we really looking at? Okay, and we couple that with another question related to the forecast mates, which are the monthly errors. So what you get, of course, in the annual is the offsetting of the errors versus what you're going to see in the mates, and we'll see that in a second. But what we see here is at first it's not all that impressive, or perhaps it's actually it's fairly impressive, that you're forecasting getting close to 1% forecast errors on an annual basis. And I think that's pretty impressive. Of course, you're getting a lot more error on the gas side. The size of the error on the gas side tends to be related to the thinner sample. We only had about 10 survey responses. You know, so that tends to be thinner, but you're starting to see those numbers settle down. They're just a higher variance. What you have here, though, is very subtly, if you're not paying attention, you can see that the 2018 numbers here tend to be, on average, lower across all the classes with the exception of peak. And if you start thinking about that, and if you were to take these residential numbers, right, we float early, call that a 0.17, there's a 0.18, right, there's a propensity to slowly tilt this line down in terms of forecast accuracy. You can see this more dramatically in the commercial side. you see things close to 2%, and then we're starting to clearly drop under 2%. We're staying here in the industrial 3s and 4s, and then we're starting to tend down to the lower 3s. So we're seeing a slow decline in the forecast errors. Now, what does that mean? It means that you're doing your jobs better. You're getting a better handle on where your sales are going. Now, that could be for a couple reasons. It could just because you're more experienced and you're getting better at your job, and I really hope that's true in all your cases. It also may be related to the idea that the flattening of the sales happened around 2007, 8, 9, and 10, and that as we come out of that major recession, it tends to be easier to forecast flatness. And as you forecast flatness, which you, on a normalized basis, assuming you've done your normalization well, it means that your errors ought to be low. So it could be either of those, but I think that we're seeing, in general, a strong improvement in the forecasting process, or an improvement in the forecasting process. Now, I said this is on an annual basis, so that's energy, forecast energy for the year against actual or weather normalized energy for the year. For the first time we asked this question is, what are your 2017 average monthly errors? Now, an average monthly error, what is that? We think of that as like our modeling mates. What we're looking at is the energy for January against the weather normalized energy for January. And we get a number, call it 3%. And we do the same thing for February. What's my energy for February against my weather normalized energy for February? Maybe that's 1%. Well, you do that for all the months, and you average the 3 and the 1, and you get 2%. These numbers ought to be higher because on an annual basis, you get the offsetting errors across different months, which means if you don't get your seasonality right in your annual numbers, that can kind of go away when you calculate your errors. If you don't get your seasonality right in your monthly data, you're going to start seeing these numbers come up. We don't necessarily understand these numbers yet because we've only seen a one-year snapshot, things that we know for certain. The residential average of 3.7% is a lot higher than the 1-point-something% that we saw on the previous slide. Let's go back. It's a 1.3%, right? So we're comparing a 3.7 on a monthly average to a 1.3. So higher monthly errors, okay, across the board. If you look at the distribution of how those errors fit, you can see that for the residential class, mostly right around here in this area. It's the 2 to 3, the 3 to 4%. Got a few outliers out here. Not so worried about you. I'm sure you guys will get your forecast in shape later. But you know, we're looking at roughly to 2 to 3% being, I think, the mode across the board of where the errors are at. So the distribution will help not only benchmark you against the industry on an average basis, but let you know how you're doing relative to other people. Are there other companies that are having more problems than you or perhaps less than you? And remember, errors aren't solely a function of modeling. Errors are sometimes a function of just your data. It's obviously more difficult to forecast industrial loads than it is residential loads, so you'd expect, and that's why we see, of course, the errors here, the higher industrial errors. So this is something we intend to begin tracking. We're going to see whether those monthly errors, the seasonality, is going to be improving over time, and how you guys get a handle on that. And we should see that come and reflect itself through these monthly accuracy numbers. Now, flipping backwards, these are the annual numbers. These are the distributions for the annual numbers. Okay. A little bit, slides are a little bit out of order, but I thought it was important to highlight the annual versus the monthly. The distributions for the annuals should be centered around 0. Some of you should be above it, and some of you should be below it after you normalize your data. And that's what we're seeing here, a nice kind of centered distribution. Generally centered here in commercial as well. When we look against actuals, the idea or the characteristics of the weather come into play, and what we're seeing here is that the left side of 0 tends to be higher than the right side of 0. What that tells us, it tells us that the actuals are below the forecast, which means the actuals came in weak. So if your forecasts are, let's call your forecast perfect, then what the actuals coming below your forecast says is that, oh yeah, I had a mild summer and a warm winter. The weather wasn't there. To the extent that there's error in your forecast, it could very well mean you just simply over-forecasted because you over-forecasted. Right? So, but what we see is that if we believe this to be primarily weather-driven, which we do believe it to be true, we're going to see the errors on the left side generally be higher than the errors on the right side. So that's a residential, that's commercial. We show system here, so higher and lower. We've got kind of the nice centered shape here. Industrials, we don't show weather normalized because it tends to be a uniform distribution. That's what we're kind of seeing here as well. The peak errors are interesting. Peak errors, what always jumps out is the bimodal nature of the errors when we compare against actual. And I think that is due to what is summer and winter peaking. So I want to ask this question. This is our next polling question. Is when you report your peak errors, I want to know what kind of utility you are. I think I got this question right. Question A says, I am a summer peaking utility, and I'm reporting a summer peak. Response B is, I'm a winter peaking utility, and I'm reporting a winter peak. Question C, or response C, is I'm actually dual peaking, but this year, in 2017, I reported a summer peak, and question response D, I'm dual peaking, I reported a winter peak, and E is I do not participate in the survey. So take a minute, less than a minute, you should know what kind of utility you are, and go ahead and fill out the survey. And this will be a quick, for us at least, a quick snapshot of the scope of types of utilities that are out there. And I think we're going to see in the future surveys a self-reporting of whether you guys are one of these categories in order for us to better parse apart what's happening on the peak. So Paige, how are we doing on those survey response numbers?
We are at about 67%.
Right.
Another second or two. And I'm closing it. 19 seconds till the results come up.
Okay. All right, I see the results did come up here. So I'm looking at 33% are summer peak errors, 12% are winter peakers. Okay, so it looks like for most part we're looking at summer peaking utilities here. Yeah, I look forward to being able to parse the data a little bit better next year, and hopefully we'll get some granularity into the peak numbers. All right, so we got a few minutes left here. Some summary slides. We've looked at sales trends and growth trends. We've looked at some forecast characteristics. We've looked at some accuracy characteristics. Let's kind of pull some of those pictures back together. Oh, actually, I'm going to jump forward a slide. These are the natural gas numbers, so we're not going to dig into those because of the small samples. But I wanted to get them up on the screen for those of you who are gas forecasters just to take a quick look at it. All right, so let's back up, pull together a few summary slides of what's going on here. I started putting this slide in the package. It's a slide I put together a number of years ago, and I seem to keep getting requests to update it. We like this view because it shows the breakdown of the economics and the sales. That's what we see in the upper left-hand corner. We got real GDP against the total United States electric sales. And when you calculate, of course, the ratio in terms of intensity, you can see that the intensities have been actually slowly declining since the early 1990s. It's just gotten more dramatic as we got past the recession. Now, the subtle thing that we see here, and the subtle thing we touched upon in terms of how we do our jobs as forecasters, is that flattening of sales and the amount of history we have. We've got 10 years of sales data that we're generating our forecast on, call it 2008 to 2017, and that sales growth is generally flat. In the past, we've said it's important to capture the bend pre-2008 because of the changing energy efficiency. You've got to get that energy efficiency in your forecast to get some sort of granularity or movement because of this very breakdown in the relationship with the economics. Well, as you move into the flat period, the temptation is to move away from the energy efficiency story because with 10 years of data, I can put in an economic driver and generate a flat forecast. Now, the challenge becomes this, is that with the general breakdown in the relationship with economics, continued use of an economic driver in the absence of accounting for energy efficiency becomes a little bit problematic because you're trying to forecast a flat line with a flat line. And as you do that, the caution becomes what are the elasticities that are going to be implied by those economic drivers. And the potential then is that you get something that doesn't quite, that looks okay optically because it's a flat line on a flat line, but the coefficients aren't quite right, the elasticities aren't quite right. And then if you start running those economic scenarios and you start levering up the economic growth, you're going to see economic growth. And in fact, what we are looking at is a world where we're running at what, call it 3-4% GDP growth, but very flat electric sales. And even if you fit that over the last 10-year period and say you get a positive coefficient on it, you know then your sales are going to be increasing because that economic or that GDP driver will be increasing in the near term. And the question, of course, is do you still believe that there's a strong economic driver, that relationship of sales and the economy? And this picture here is just a nice reminder that, yes, we have a slow breakdown in this relationship, and as forecasters, we still need to be smart enough not to just use pure economics without accounting for things like energy efficiency changes and not accounting for weather and things like that. So I was talking to one utility, and they had an executive who was very interested in just using a 3-year average. And while that might work very well, the stories all break down with the 3-year average because they have no indicator of what's going to move in the future and no way to make it move. So our job as forecasters continues to be important to try to find those significant driver variables of how energy moves. And of course, the beauty is we understand energy. We understand how people use energy. And therefore, we can get those types of drivers into our model. All right. So last couple pictures here. This picture, when you roll the picture together, where are sales going? This shows the historic United States 12-month rolling sums tacked onto it at the very end. What you said was growing, your systems are growing at, which is about 0.5%. So there's the picture. Once again, very interesting that the picture shows flat recent history, yet still the forecast shows a little bit of lift. That lift is within the bounds of the noise, but it still shows the lift. On the gas side, we see something very similar. We see the returning of natural gas back to kind of its all-time peaks. We still see a little bit of lifting in that forecast within the range of reasonableness, but still a lift as well. And then, of course, I like to put in this last picture here. These are your forecasts over the last, I got what, 1, 2, 3, 4, 5, 7 years shown here. And this is just like most of you see individually in your systems. Call it a fan, a peacock, something like that, where back in 2011, the whole idea was that sales were going to return to historic trends. And as the flattening of the sales come in, the forecast each year gets ratcheted down. And that's what we're looking at. The dark blue line becomes 2018 forecast, both your short-term and your long-term forecast from the survey, and it continues to project out, slowly evolving to something flatter and flatter. So those are the 2018 survey results. Hopefully, once again, the overall themes, there are no dramatic surprises here, but I think as we start seeing multiple years of data come forward, we're starting to see the slow evolution of trends. We're starting to see stronger benchmarks that we can use to evaluate our own performance and build, once again, a comparison of our utility story against what's going on across North America. With that, just a couple closing slides, and then we'll take a few questions. First, a reminder that we have a forecasting blog out there. It's a great place to keep in touch with us, to get some of our thoughts on either what's going on across Itrom, or specifically the Itrom forecasting business, as well as a few interesting thoughts about observations that we're seeing in the industry. So keep your fingers on our blog website. And then, of course, the last slide is upcoming training opportunities. We got our workshops and meetings listed here. So we do have a workshop, a long-term forecasting workshop coming up in Chicago in October. The short-term forecasting workshop in September out in San Diego. So those are the near-term ones. We have just reserved dates for Forecasting 101 in February next year in San Francisco, and here's my tip. Travel tip for Forecasting 101 is, if you're going to go, book your hotel early. San Francisco seems to be a hot conference spot, and when those hotels book, they book very fast. I actually was looking at hotels in San Francisco at the end of the month. There's a large conference coming in to the San Francisco Convention Center, and literally anything 3 stars and up is booked. So if you're planning on coming out to Forecasting 101, don't wait till last minute. If anything, go ahead and book your hotel, get your approvals in afterwards, and when they approve it, then you can finalize your travel arrangements, or you might find yourself staying in some undesirable place. Okay,
Mark,
so
with that same note, EFG meeting next year, it's seeming like Boston is very crowded. So as soon as that announcement comes out, please go ahead and register for that and book your hotel when that comes out as well. Yes,
because nobody wants to be staying 20 miles out away from the conference location. All right, so you see the dates here. I mentioned the EFG meeting April 3rd through 5th. We are bringing a guy out from the Storage Alliance. That's already booked, and I think Aaron's already booked coming out from the EIA. We're hoping to bring together a nice agenda to at least give us awareness into all these topics. And of course, once again, it's a great networking opportunity for you to meet some of the other forecasts in the business and to compare notes on the issues that you're facing. All right, so those are all my slides. Thank you for your patience. Let me go and open the lines up to see if there are questions. I see a few coming in. I got one question. I'll go ahead and read them off, and we'll see if we can answer them. First question comes in from Kathy. For those companies incorporating energy storage, are there any indication of impacts affecting sales or peak or both? Great question, primarily for you out there who are listening. What we're looking at in terms of storage impacts is this. First and foremost, we think storage tends to be a healing technology, an opportunity to levelize load. We also know from an engineering perspective, the energy you put into storage, you can't get out. So it's always a net loss. So when you think about storage, it should be on a monthly kilowatt-hour basis or an annual kilowatt-hour basis. It should be a load-building technology, but it also should be a curve-flattening technology. So while energy might be going up, the impact on peak, in theory, might be coming down a little bit. Now, once again, we're not seeing a large penetration of storage yet. The issue of shaping becomes a very challenging issue because, like electric vehicles, I think early adopters are going to behave very differently than mass adoption. I don't know what people are looking at, but those are the things we're starting to hear out in the industry. So hopefully that answers your question, Kathy. Second question comes in from Stephen. What forecasting methodologies are used the most frequently in these forecasts? Linear regressions or something else as well? This is actually a question that we do ask each year. I didn't show a slide on it, but the question is, let me see if I can find it over on my computer. What method are you using to generate your residential forecast? And let me go read off some of those results to you. We've asked this question for generally the last 4 years, 2015 to 2018. The three responses we offer are econometric, statistically adjusted in-use, which is an econometric model with in-use components in it, or other. So for the residential 1 year ahead forecast, the econometric only, which would be your linear regression type model, is, we're going to call it about 38%. The SAE model for residential 1 year ahead, that's the econometric with the in-use components in it, that runs about 50%. And the other sits around 10 to 15%. Now, other we don't know. Well, actually, we do know. Other from the individual responses tend to be trending methods or average methods. We see a similar response into commercial. The commercial segment runs about 50% econometric, about 45% SAE, and about 10 to 15% in other. 50%, we'll call it 35% SAE, 40% SAE, and about 10% others. And those numbers are very similar when we go to the long-term forecast. The numbers I just quoted you were ballpark numbers from the 1 year ahead forecast. We have 10 year ahead, or basically the long-term forecast as well. Those will be sitting in the report that we publish later in the year. Okay, so hopefully, Stephen, that answers your question.
Mark?
Yes.
Do you have an estimate on when we're going to release that report?
I can give you an estimate, but that would commit me to actually writing the report. Well, you know, once again, we hope to get it done by the beginning of Q4. So today, I'm going to tell you October. Maybe. Depends how busy I get. All right. I got one other question from Aslam. How will energy efficiency impact energy and demand in the next 10 years? You mean, how will energy efficiency impact energy and demand in the next 10 years? Besides lighting, what's the next most significant technology that would bring more efficiency? Generally, we see a decline in intensities or usage across the residential sector. Lighting tends to be the most dramatic. And off the top of my head, I'm not sure I have a number per se for you without looking it up. I think most of the technologies besides lighting tend to be stable. I think you're going to see increases in the miscellaneous category, if I'm not mistaken. I think the big wild card out there is going to be electric vehicles. We are watching every major auto manufacturer indicate that they're going to be putting something out over the next 2 or 3 years. These are not the small 100-mile cars. They're talking about long-range vehicles, 200 to 300-mile cars. And that has a potential dramatic impact in terms of raising. So I'm not sure I answered your question, Aslam. But that's what I can think of off the top of my head. Okay. I got a question coming in from Prajan G. With GDP and energy intensity losing correlation, how prudent is it to incorporate GDP in your forecast? And I think the answer is it's as prudent as it fits your data. Generally, our long-term forecasts from an economic perspective are driven either by population, households, some form of output like a GDP number, as well as employment. What we hope to see in all of those are small elasticities, right? And elasticities bigger than 1 are going to feel a little bit too aggressive. We like to match our outputs and our employment with the industries in your region. So GDP at a national level might not fit, but perhaps GDP for your local area or your MSA based on the industries in your area actually may fit much better. I'd be remiss to say you can't take the national number and say there's a breakdown. without doing your homework and asking the question of what's happening locally as well, identifying to see if those correlations are breaking down. In general, we like to look at employment and output, and in many cases, we'll weight those economic drivers together in the context of an SAE model so that we can blend those economics with the end-use information, the efficiencies and saturations. All right, so hopefully, Dr. Schill, that answers your question. Are there any other questions out there? I've gone 6 minutes over, so I apologize for stealing my lunch hour and your lunch hour. And of course, if you're not in the West Coast, hopefully you've already had lunch. Okay, so with that, let's go ahead and wrap this up. Thank you for attending. Hopefully we'll see you come out to the EFG meeting out in Boston so we can connect and we can talk more about some of these issues and what's driving these issues. Remember, book early. At a minimum, book those hotels early because you don't want to be caught out at super expensive hotel rates or quite far from either the conference site. So with that, thank you for coming and thank you for listening. We'll see you later. Bye.